Welcome, everybody, as we dive into 2B of our module. So, I will be able to compose functions. Well, why don't we do that? I will be able to compose functions. But wait, we still have this guy right here. Little clown face here. What does it mean to compose functions? Well, if you remember from previous, let's fix this. If you remember from previously, and let's skip all this right here, that's important, but the basic conceptual understanding is you're going to take one function and you're going to have the inputs go in and come out, and then they're going to go in the other function and come out. So now, after this is the second time we're going through this, briefly touching on it though, I want you to re-explain this concept in 10 words or less. Go ahead and write it on your worksheet as well as your Edpuzzle. Going on in 3, 2, 1. All right, guys. So we're going to compose functions using equations. So we're going to find two different sets right here. We're going to figure out, the function of f of g of x and g of f of x right here. So basically, we're saying, hey, take this g of x, and this is going to be, hey, figure out what g of x is and put that inside f of x. So what I'm going to do right now is I'm going to substitute. What is g of x? Well, I'm going to circle it right here. G of x is 3x. So I'm going to say f of 3x. That's g of x right here. So I'm going to substitute. So instead of saying g of x, I'm going to say 3x. So I just substituted. Well, what is f of x? Well, if f of x is equal to 2x minus 5, then I know that 2 of x minus 5, this x being this part right here, I'm going to be throwing this 3x in right here. And what did we just do? We just substituted again. Well, now we just need to multiply and get it done. So this will equal 6x minus 5. It's a line. It's a linear because it has a implied degree of 1. So what does that mean? Well, our domain and range will both be all real numbers. All real numbers. All real numbers. Now, why don't you try this next one? And we'll talk about that. We're not going to stop at that. We're going to talk about why. Why don't you try to figure out g? So g of f of x. What is that equal to? I'm going to stop. I want you to try to do this one in 3, 2, 1. All right. Hopefully you tried it. Now let's try this out. So we're going to have g of f of x. Now I'm going to take this, whatever f of x, and I'm going to plug it back inside. So f of x is 2x minus 5. And what did we do? We substituted. We substituted 2x minus 5 for f of x. All right, well now I'm going to go back. I'm going to substitute what g of x is. It's going to be 3 times whatever our input is. And wouldn't you know it, our input is 2x minus 5. And now, we've been doing this with a negative. We're going to be multiplying that 3 using the distributive property. So the first one we did, we substituted. And then this red part is distributive property. Or we distributed. And so we should get 6x minus 5. Hey, wait, it's the same line. We'll talk about that at a later class. So we'll have the same, we're going to have the same domain and range. Go ahead and write that here and here. No, don't just draw arrows. I want you to write it. So write this right here. Don't put stars. I want you to write it. What is the domain and range of 6x minus 5? Now hold up. I'm going to post something down below in 3, 2, 1. Okay, guys, this is very important. We're going back to 2.5, 2.7. Here is this equation. You might be wondering, well, how do you know the domain and range are all real numbers? Well, if I understand this is going, if I can input anything, can I input everything going this way for x? Yes. So it's going to be all the numbers from 0 to infinity. Can I put, is there anything stopping me from going 0 to negative? No, there's nothing stopping me. So I can go to negative infinity and I can go to positive infinity. There's nothing stopping me. Now, how about the y value? I'm going to be going up and I'm going to be going down. So that means I'm going to have all the real numbers for x and all the real numbers for y. Our domain is x and our range is y. Now, we're only going to have things are going to be we're not going to have certain values. For example, if I have x squared. So here's x squared or x to the 4th or x to the 6th. I'm just going to say, hey, it's any even number. So if I look right here, it will let me go all the way to the left. It will let me input all the numbers to the right. So my domain would still be all real numbers. But my range, there's a minimum right here. Let's say this is 1 or something. I don't know, y equals 1 right here. Let's say. So then that would mean my range would equal y is greater than or equal to 1. Because it starts at 1 and it goes forever up. It goes forever up. So the domain would be all real numbers and the range would be y is bigger than 1. Because that's the lowest point it is. That's it. So you have to understand polynomials and understand, all right, what's the shape, what's the end behavior, so we can talk about domain and range. That's the whole point. Well, that's not the whole point, but that's one of the points we need to talk about. Will you get all the numbers for domain? Will you get all the numbers for range? What if you have something like this? What's the domain and range of that? But I digress. All right, guys. You have a wonderful day, and I'll catch you guys later. Bye.